So the next situation we're going to be going on to is particles along an inclination. So a good bit of vector knowledge is going to have to be known here. So if you skipped vectors just to go to forces and dynamics, I recommend you go back to vectors, otherwise you'll be slightly confused as to what's going on here. So when dealing with particles on an angled surface, we need to split the weight force up into components, just like we've done with normal vectors. One parallel to the plane and one perpendicular to the plane. So we've actually been doing this before, however, our actual angle, so our angle of inclination has just been 0 degrees. So we'll find out that the weight force causing acceleration, so the weight force causing the acceleration, is actually sine theta. So that's why on an inclination of 0 degrees, the acceleration is 0, or well, the magnitude of the weight is 0, but the other part of the weight is actually cos theta, and cos of 0 is 1, so that's where all the weight is going here. So in order to illustrate this, here is a diagram of the resolving forces. Now, this might look slightly alien, but I will go through it. So, firstly, the reaction force is directly perpendicular to the plane. That is consistent with all reaction forces. They're always perpendicular to the plane at which the object is sitting on. Here is our angle of inclination theta. If we work with right angle triangles, so the weight force will be perpendicular to a horizontal axis acting through, so it's almost like the ground per se. So this angle is always a right angle. So this angle in here is 90 minus theta. Now, because the reaction force is acting directly perpendicularly to the plane, this angle in here is also 90 degrees. So the missing angle here is theta. So what we can do is we can split up our weight force into components. One that is on the same line of action as the reaction force, or perpendicular to the plane, and one that is parallel to the plane. In doing some resolution of vectors, the parallel component, which is written as W with 2 lines, is mg sine theta. The component perpendicular to the plane is mg cos theta. What we can also notice is that these forces are balanced because the particle is not taking off from the plane or sinking into the plane. So the reaction force is actually equal to the perpendicular components of the weight, which is mg cos theta. So that's a handy conversion to know. Without friction as well, the acceleration down the plane of an object is g sine theta, because the acceleration mg sine theta is equal to mass times acceleration. So cancelling the masses, the acceleration down the plane will be equal to g sine theta. So as just a quick recap, the parallel component of the weight is mg sine theta. The perpendicular component of the weight is equal to the normal reaction force, which is equal to mg cos theta. And the acceleration, assuming no friction, of a particle on an incline theta is g sine theta.